In this video, we look at an exam-style question about friction, acceleration, and work. At the first glance, it looks like a really long question with a lot of text. So my strategy is always to highlight the numbers in the question to figure out what the available conditions I have, and then go through the A, B, C part of the questions step by step. So let's have a read. A contestant in a winter sporting event pushes a 50 kg block of ice across a frozen lake. So the first number here is a mass quantity. So I'll put M next to it. Next bit says the coefficient of static friction of ice on ice is 0.09 and the coefficient of kinetic friction is 0.02. So it looks like we're given two different coefficients. So a static one, 0.09, and a kinetic coefficient for 0.02. And I'll write the two symbols next to the numbers. So mu s for static and mu k for kinetic. Okay, next read the questions. First says calculate the minimum force he must exert to get the block moving. So whenever you see questions like calculate the minimum force so that the friction is conquered, or the maximum force that you can put on before the block is moving, that's basically asking for the maximum friction. It's asking for the situation where limiting equilibrium happens. So that means it's simply asking for F max, which we know by formula is mu times normal force. So which mu should we be using? We need to use the static one because it's the force that you need to use to conquer the static friction, conquer the friction that stops the block from moving. So I will have to put mu s in here. A normal force is simply mass times g because it's on a horizontal lake, so it equals to gravity. And plugging in all the numbers, 0.09 times mass of 50 kilos times g for the earth, 9.8, that equals 44.1 newtons. Okay, question 1 is done. Part A is done. Part B, what is the magnitude of its acceleration once it starts to move if an 80 Newton force is applied? So this 80 Newton force is trying to move this block, therefore this one is my driving force. And it's asking for acceleration, so we have to invoke the Newton's acceleration formula, force equals ma. Now again, just like I said in the previous video, you have to know that this force is not just any force. It's definitely not frictional force. It's not a single force. It's the net effect of all forces, so the resultant force. In this case, we have a driving force that's trying to move the block, and the friction force is trying to stop it or slow it down. Therefore, the net effect of the resultant force is my driving force minus my friction force. Now, I can't use the friction force that I calculated from part A because that is a maximal static frictional force. When part B, if the block is actually moving, we'll have to calculate a kinetic friction separately. So F of friction in the kinetic scenario is going to be my mu k, then mu k times mg, plugging in the numbers, 0.024 mu K times 50 kilograms times 9.8, and the answer is 9.8 newtons. And then now we can use our resultant force formula. F resultant equals driving force is 80 newtons minus 9.8, and that should equal to my mass times acceleration. So 70 equals 50 is the mass, A, no, 70.2, sorry, and acceleration is 70.2 over 50, and that equals 1.404 meter per second squared. So that's part B done. Last section of the question, part C. If the block is pushed over 25 meters across lake, what's the work done against friction? We know the work formula is simply force times distance, and there's nothing fancy here at all. It's just simply asking for the work done against friction, work done by friction, so work related to friction, and it's just simply frictional force times the distance that the friction is acting on. So if the block is pushed over across 25 meters through the whole time, friction will be acting on the block. So simply the frictional force that we've calculated in part B when the block is moving, which is 9.8 newtons, times the 25 meters, and that equals 245, and everything's standard units, so use work and energy units, joules. And that's the end of a similarly very long question. As you can see, if you mark out your quantities and do the questions step by step, it is actually not scary. All right, thank you for watching.